Okay, part B, remember the directions are decide if the given series converges. If so, find the sum. Really, you find the sum and then, yes, it converges or not, right? So you really find the sum first if you can. But that's how I think that's how your book puts it. So that's how I wrote it. So now we have the sum from n equals 1 to infinity, a single fraction, 2 divided by 4n squared minus 1. We've got to figure out what to do here. If you write it out like we did in the last time, you're not going to see any kind of cancellation pattern. But this one is a telescoping series in disguise. And you're going to have to write it as a difference of two rational functions to see it. Do we have any tools in our toolbox for doing that? For writing a single fraction as a sum or difference of other fractions? What's that tool?
Partial fraction.
Partial fraction. Yeah, you thought you were done with that, but you weren't. It keeps coming back. Okay, so I'm going to take just the an, if you think of that guy as an, and I'm going to write it as well. Let's go ahead and do it right in this step. Let's factor that denominator. And what do you get when you factor 4n squared minus 1?
It's 2n plus 1 minus 1, right?
2n plus 1 times 2n minus 1. Two non-repeated linear factors. And the idea is I'm doing partial fraction decomposition on this thing. And I'm hoping that I'll get a minus in between the two fractions, and I can use the same trick I used in the last problem, the telescoping sequence. Or telescoping series, really. P, that's a PFD, partial fraction decomposition. So two non-repeated linear factors, how do they break up?
A over 2n plus 1.
A over one of the factors, 2n plus 1, and B over 2n minus 1. Let's use that shortcut. But whether you're using the shortcut or not, what do you have to do first?
Both sides by CD.
Okay, multiply both sides, right?
Yeah.
Two. I knew you meant that. I do that all the time. I say the opposite thing of what I mean. The worst thing is I'll call my son by the dog's name. Okay. So on the left-hand side, it's nice. You just get 2. What do you get on the right-hand side?
A2n negative 1 plus B2n plus 1.
So A times 2n minus 1 plus B times 2n plus 1. And I definitely do recommend that shortcut here. What do you want to let, in this case, n equal?
1/2.
Sure, 1/2 is a good one. So when you let n equals 1/2, the left side stays the same. And what do you get? Well, when it's 1/2 here, this whole a term goes away, right? You get a times 0, 1 minus 1. And then what do you get over here? So 1/2 right there. B times 2, 1 plus 1. So what's B going to equal? 1. And then you might be able to guess what A equals, but let's see if we're right. What's another thing to let n equal? To get the B term to go away. Not plus 1/2, but negative 1/2. So in that case, if it's negative 1/2, then what do we get? A times, we'll get 2 on the left side, and then A times, well, that's 2 times negative 1/2, which is negative 1 minus 1, so negative 2, which means A equals negative 1. And this guy, remember when you plug in negative 1, this guy went away. I didn't put in the plus B times 0, but it went away. Oh, so then the decomposition is what? Well, okay, so we get the original sum then, n equals 1 to infinity, 2 over 4n squared minus 1 is equal to, okay, put in the decomposition where this guy 2 divided by 4n squared minus 1 was. What does that decompose to be? So you got to fill in the A, fill in the B right here. What do you get? Oh, and maybe switch it around so you have the minus in between. So maybe make it B over 2n minus 1 plus a over 2n plus 1. What would you get?
Same thing as the last example.
Oh, yeah, you're observant. So 1 over, so if I, 1, this guy's 1, over 2n, whoops, minus 1. One over 2n minus 1, and then a is minus, so minus 1 over 2n plus 1. Oh, is that the same as what we had in the first example? I'm hoping it was, so I don't have to do it all over again. Yeah, so 1 over 2n minus 1 minus 1 over 2n plus 1. So that'll save us some time. We've already done this, right? This guy we know for sure from the last example is a telescoping series, so I won't do all that over again. We know that that equals what? 1. So I'll say C, last example. And I'll mention that this is a telescoping series because that's what we were hoping for. Almost like somebody designed it that way so we wouldn't have to do all that work over again.